Uh, Welcome to our NJAG meeting. We're going to do a presentation here to begin our program. I'm going to talk a little bit about the upcoming Mars mission. And after that is over, I'll have time to go into our business meeting. But for the presentation, at any point, if anyone has any questions, feel free to stop me, and we could take some questions during the presentation, and of course at the end as well. And of course, as you all know, Mars is prominent in the evening sky right now. And so it's a good time to talk about this upcoming mission, the Perseverance mission, or Mars 2020, as NASA likes to refer to it. And so before we get into the details of the mission, let's review just a few basic facts about the red planet. It's really a fascinating planet. We've been interested in Mars for quite a long time. We've been talking about the possibilities of life on this planet for a very long time, going back, more than a century at this point. And so just keep in mind that Mars is a pretty small planet. It's about 53% the size of Earth. It's 4,200 miles across, and so it's about half the size of planet Earth. But its mass is really only 1/10. Even though it's half the size, it's only 1/10 the mass, and so quite a bit different than what we're used to. And so that, of course, makes the surface gravity on Mars quite a bit less. If you weigh 100 pounds here on Earth, you only weigh 38 pounds on Mars. It's a great weight loss program. I highly recommend it, the Martian weight loss program. So the surface gravity is really quite different. Of course, Mars does have 2 moons. A lot of people forget that it does have satellites, but a little bit different than the satellites we're used to around most of the planets in the solar system. This is really 2 kind of captured asteroids, 2 chunks of rock that have been captured by Mars, and so perhaps they're from the asteroid belt. And you've got Phobos and Deimos. Deimos is only about 8 miles across, Phobos about 14. So really very small objects orbiting around these 2, around the 4th planet. Phobos and Deimos, you might wonder where those names come from. They mean fear and panic. And that sounds kind of scary, but remember that Mars does represent the god of war, and so fear and panic always accompanies war, and so that's where the names come from. The day on Mars is really quite similar to Earth's, but it's a little bit longer, 40 minutes longer than Earth's day. And when you hear about NASA missions, they often refer to the Martian day as a sol, S-O-L, sol, and so you hear that used quite often to measure time. Mars is also quite a bit further out in the solar system, 142 million miles from the sun compared to 93 million miles for the Earth. So it is a bit further out there. And as a consequence of that, of course, the orbit of Mars is different. It's moving much more slowly there, out there beyond the orbit of the Earth, and so its year is just about twice as long. It's 687 days long, and so it is a longer year. And so you've got 1 year on Earth, and 2 years will pass on Mars. The temperature, of course, is quite different as well. Here on Earth, the average temperature about 57 degrees Fahrenheit, but for Mars, being further away from the sun, the average temperature is around negative 81 degrees below zero. And so it is quite a cool planet. Sure, it can get warm. Sometimes you'll get a nice warm day on Mars, during the summer, if you're standing on the equator at the hottest time of year. Yeah, sure, the temperature sometimes can get up to about 70 degrees, but that's about it. Most of the time, it's much colder than that. And so in the winter, at nighttime, you can get down to almost 300 degrees below zero near the poles. So it is quite a cool planet. The structure is probably quite similar in terms of just overall. You've got a crust and a mantle and some kind of liquid outer core, a solid core for the Earth, at least. For Mars, well, we're really not sure exactly what the structure is. It may not have a liquid outer core, but that's something that we're investigating right now. Speaking of spacecraft, the NASA InSight spacecraft is on the surface now. It's been there for a couple of years now, I think, and it has a seismograph on board, and that can be used to listen for these Mars quakes and determine, hopefully, what the inner structure of Mars is like. We've got lots of very detailed maps of the surface of Mars. We'd like to know a little bit more about the interior, and that's what the InSight mission is all about. So similar interior, atmosphere, at least Mars does have an atmosphere, but it's about 100 times less dense than the Earth. So it's really quite a thin atmosphere, whereas Earth, of course, is 78% nitrogen, 21% oxygen, and 1% of other stuff. Mars is 96% carbon dioxide, so definitely not a breathable atmosphere from a human point of view anyway. And it is a very thin atmosphere compared to Earth. And so that's something you have to keep in mind as we plan some of these missions going forward. And so even though Earth and Mars, we consider them to be fairly similar, there are differences. So even though that you've got something that's a very cold planet, very thin atmosphere, really, if you compare it to the other planets in the solar system, Mars is really the most Earth-like planet. And that's one of the reasons why we're so interested in this world. And it is nearby to us, and especially right now, it is close to us. It's at its close point. I think October 13th, if I remember correctly, was the close point, the opposition of Mars, I should say. And so that's always a good time to launch a spacecraft. If you want to have a quick trip to Mars, you always want to launch near opposition or just before opposition. And so that was the case this year. July 30th, the Perseverance rover mission launched July 30th, 2020 on Atlas V rocket taking off from Kennedy Space Center down there in Florida. And so this mission is on its way. And in fact, if I remember correctly, yesterday was the 100-day mark. There's 100 days left in the journey to Mars. And so here's an artist's rendition of what the Perseverance rover looks like. And of course, NASA scientists, they like to give everything nicknames. Sometimes they'll hear them refer to it as Percy for short. And there's also Ingenuity, which we'll talk about in a moment, which is a really cool little craft that is being carried on board this particular mission. So the Perseverance mission is on its way to Mars. You might wonder where the names come from. These are the two students, Alex Mather from Virginia and Veniza Rupani from Alabama. And they named the rover, Alex named the rover Perseverance, because in order to succeed, you have to persevere. And Veniza also suggested Ingenuity is a good name for the rover, but they kind of awarded the name Perseverance to the rover and decided the other name was so good, they assigned it to the drone that we'll talk about in a moment. So you've got Perseverance and Ingenuity. And to give you an idea of the size of this rover, here's the rover compared to a human as well as other rovers. You've got the famous Pathfinder mission, the Sojourner rover, the very first successful NASA rover on Mars. And then you had Curiosity and Opportunity, the two previous rovers that operated on Mars for, I forget how many years, quite a number of years. And now the Curiosity rover is operating right now, still operating on the surface and sending back some great science for the past several years. And Perseverance is just about the same size. It's a little heavier, a few hundred pounds, if I remember correctly. So it's a little heavier, and some of the instruments are a little bit different, which we'll talk about, but about the same size as the Curiosity rover. And this gives you an idea of how big it is. It's really quite a big spacecraft. If you think about it, next time you're out and about, take a look at a Mini Cooper. If you see a Mini Cooper driving around, that's about the same size as the Perseverance and Curiosity rovers. And so here's a little video here. This is very short, but I think for a rather spectacular dramatization of what what it takes to get one of these rovers on the surface. This was originally produced for the Curiosity mission, but Perseverance will land in exactly the same way. And NASA likes to refer to it as the 7 minutes of terror.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow, constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the sky crane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit it on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage is in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
Yeah, and so that was the landing on August 5th of 2012, and Curiosity has been on the surface since then. And so, whoops, I don't want to restart it there. Let me go on to the next slide here. So yeah, that's pretty crazy, right? It's a pretty nutty way to land a spacecraft, but previous missions such as Pathfinder, we used airbags to land on the surface, but Curiosity and Perseverance are just too big for that. The airbags would just simply rupture. And so they came up with this crazy idea to land the spacecraft using this weird sky crane, and well, son of a gun, it worked. And so we're doing the same thing with this particular mission. Now, where it's going to be landing is called Jezero Crater. And this actually was a target originally for Curiosity, but they were worried that they did not have a precise enough landing system to be able to land. They were afraid they were going to hit, a big boulder. They didn't know what they were going to hit. This site was perhaps a little bit too dangerous, and so they opted for a safer landing spot. But for this mission, they've improved the landing system, made it much more intelligent, and so they felt confident that they could land in this slightly more dangerous area, but much more interesting area. So this is about 28 miles wide, this particular crater. It's located near Sirius Major, not too far from the crater. I think it's just north of the crater, if I remember correctly. And its name comes from a Slavic word meaning lake. And this really is probably a body of water was in this particular crater. And you can see this beautiful sort of delta structure here where water or whatever has flown through this channel and out into the floor of the crater. And so really, really fascinating area that we'd love to explore. And so this is the target area for the Perseverance rover. And so this is what the rover may look like once it touches down and starts exploring its surroundings. And so you might wonder, well, what's different about this particular mission? We've sent rovers before, why do we need to send another one? Well, the mission for this particular spacecraft is a little bit different than previous ones. Of course, it'll look at some of the same things, like looking at the chemistry of the rocks and that sort of thing. But its main mission really is life. We want to look for signs of life, or really look for if there's any signs of life in the past. Some kind of fossilized life, perhaps, or some signs that life has existed in the past on Mars. And so it has kind of a life focus for this mission. And I have a little overview here of the mission. It's, again, another short video, about little under 3 minutes long. Was the audio okay for that video that I just showed? The volume level good on that?
That was fine. It was much better.
Yeah, okay. Once I fixed it, yeah. So this should be good too. So let me play this little overview of the whole mission.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms. And it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
Okay, so there's a little overview of the mission and some of the instruments that the rover carries, the Perseverance carries, are similar to what Curiosity carries, but as I mentioned in the video, some of them have been upgraded. And so, for example, the mast cam, the panoramic cameras that are located up on the sort of mast here, those are panoramic cameras just like Curiosity, but these are zoomable. You can zoom in to different items around the spacecraft. You also have the super cam, which just like Curiosity has a laser. You can fire that laser and check out what chemicals the rocks are made of. Media is Meta is a weather station. We'll take a look at the weather around the rover. There's RimFax, which is a subsurface radar. I'll talk about that in a moment. Of course, Sherlock and Watson, Sherlock Holmes, he's going to have a big magnifying glass in his hand to examining things up closely. And so Sherlock on this spacecraft is an ultraviolet spectrometer, and Watson is a close-up camera you can use to examine soil samples and things like that. And it also carries an X-ray spectrometer as well. One of the fun experiments on this mission is called MOXIE. And MOXIE is really an interesting experiment. What it's going to do is going to take in carbon dioxide from the atmosphere. And of course, carbon dioxide is CO2. Split that up and you've got oxygen. And so you can create oxygen on site. And so this is just an experiment for future missions. If we ever do send astronauts to the surface, it'd be nice to be able to generate your own oxygen on site, which is really be very useful for these particular missions. And so that's some of the instruments that it's carrying on board. You've got some very nice high-resolution cameras, much improved navigation systems on board, and so the rover can travel over longer distances. Also, another upgrade for Perseverance is they upgraded the wheels, and many of you probably have noticed that over time for the Curiosity rover, if you see a picture of the wheels, they're pretty shredded. It turns out that the landing site, the rocks were much harder than they originally thought at the landing site. And so the hard surfaces have really torn up the wheels on the Curiosity rover. And so Perseverance has an upgraded set of wheels to help with that sort of thing, help it last much longer. And as mentioned, one of the cool things about this mission is that it carries a drone. This is the very first time that we're going to attempt to fly a spacecraft on the surface of another planet. And so you have Ingenuity, this little 4-pound drone here that will lift off the surface. It's actually right now it's nestled under the belly of the rover, and so once it lands, it'll drop the Ingenuity drone onto the ground, and it will unfold and then be able to fly off. I think the maximum range is about 30 feet, and is really it is not very sophisticated. It's really meant as a technology demonstrator. It has a downward-facing camera that can take close-up pictures as it flies around. But that's the only instrument it really carries is a camera, and so it can allow the rover to cover a larger area. And if it's successful, well, we can use that to create other types of flying spacecraft for other planetary missions. And so it's kind of exciting to see this go on. They do call it a flying drone. It's more of a kind of a hopper though, because it does have a limited range. It'll kind of lift off and it'll have these short hops that it jumps across the surface. I think the flights are, if I remember correctly, about 90 seconds long. And so it'll just kind of hop across the surface. but still kind of a really neat little drone there that it's carrying. One of the instruments mentioned was a ground-penetrating radar. That's something that Curiosity does not have. And so not only is the Perseverance rover exploring the surface of this planet, it is probing down beneath the surface as well. So we can see a little bit more about what the structure of the underlying layers are. So that's also another interesting aspect to this particular mission. And as mentioned, the rover will be taking samples. It'll actually be doing these little core samples. It'll drill into the rock and pull out these cylinders of rock and putting them into these little containers. And those little cylinders will be left kind of like breadcrumbs across the surface of Mars. And in the future, these could be picked up and returned to Earth. And so how is the rover going to do that? How are we going to do that? Well, it has to be done by a second spacecraft. And so the European Space Agency has partnered with us on this. And so they're building a lander that will, in a couple of years, will land on the surface of Mars near to the Perseverance rover. And on board that spacecraft will be what they call a fetch rover. So this is like a little dog that you go and fetch things for you. And that rover will go out and retrieve the cylinders and bring them back to the main spacecraft. And then eventually, once they've collected all those little cylinders and packed them into this little container, that will be fired back to Earth. And we can bring that back to Earth and put it into the laboratory and do some testing on those rocks. That's all exciting, but as mentioned in the video, that's going to take a while to get that particular project done. And so they're talking probably the early 2030s is when we'll have these samples back in hand, which is quite a long way in the distance, but still pretty exciting to have actual pieces of Mars to look at up close. So very interesting mission. And of course, this is headed towards a possible crewed landing of Mars that would take place sometime in the future. Of course, NASA is working currently on the Artemis project, and the Artemis project is designed to send astronauts back to the moon. And so that would take place first, and then eventually onwards to Mars. Now, of course, as many of you know, NASA is working on a timeline is really quite a little bit unrealistic at this point. They're talking about landing the first man and first woman on the surface of the moon since this is the Apollo program in 2024. And while that's only 4 years away, and they don't have a lander, so it's kind of hard to plan a landing if you don't have a lander yet. I think the designs, a number of companies submitted several designs for a lander back in September, but none of those contracts have been awarded yet, and so they have not even started building it, and I'm not even really sure if it's been funded quite yet by Congress. So kind of hard to have a landing without a lander. A lot of people, I think, are very skeptical about the 2024 date, but at some point in the next few years, we could land astronauts on the surface of the moon and use those experiences to help us get to Mars. And things like the MOXIE experiment will really help us to plan those missions. Very difficult to get the supplies that you need for one of these missions because it is a long journey. You know, we launched Perseverance in July, at the end of July, and it won't get there until the middle of February. So you have a several month trip, and then you're going to spend some time on the surface and then several months back. And so you need to have quite a lot of supplies in order for a mission for this to be successful. And if you can have some shortcuts, like being able to create your own oxygen, or perhaps figure out how you can supply water to your astronauts more easily. Those are both really important things to keep in mind for a crewed mission like that. So that's possibly in the future. And as mentioned, this rover is now 100, or now I guess today is 99 days out from landing. And so that's going to take place on February 18th of 2021. And so definitely keep an eye on the NASA website for that information as we get closer to the landing. And so we can look forward to hopefully a successful landing where that crazy sky crane system will go into effect and put this onto the surface of the red planet. And as time goes on, of course, hopefully we'll find out more information about the surface of Mars and the possibility that there was once life on this planet, perhaps. And so I hope you enjoyed my little presentation here all about the Mars rover, the next Mars rover. And so if anybody has any questions, I'll be happy to answer any questions that you might have. But let me take a moment here to give a little shameless plug here for a program I've been working on at the Newark Museum. We have had this year a couple of community days. Back in September, we did Dino Day. And so this month, on November 21st, we are doing a community day that's all about space and astronomy. And we call it Astrofest. And actually, some of you have helped out with some of our previous Astrofest events. We've had two of these events previously, and a couple of our NJAG club members helped out with solar observing for some of those events. And so this one is taking place online. Of course, the museum is still closed to the public, and we're doing virtual events. So this is going to be on Zoom and also on Facebook Live. And the kind of main event of the day is we're going to have former astronaut Mae Jemison, the first African-American woman to travel into space, is going to be our kind of main speaker at about 1 p.m. in the afternoon. And so at some point, I'll put a link to the event in our little chat box here. You can check that out. The registration is free. Of course, donations are appreciated, but it's a free registration. And feel free to spread the word if you know anyone else who is interested in this sort of thing. The day is kind of focused towards kids. They get kids interested in science and astronomy and STEM careers and that sort of thing. But it has a few other things that we'll be doing that are of interest to adults as well. And so if anybody has any questions about Mars or the Mars rover, I'll be happy to answer any questions you might have. Feel free to unmute yourself and ask away. I'm going to stop my share here so that we can see each other.
Hey, yeah. Kevin.
Hi, Kevin.
Yeah.
It's Terry.
Yeah, hi, Terry.
So, one of the problems I had in the previous missions is that they had solar panels for the rovers, but they eventually died, because of lack of power, but also the harsh conditions, the cold, the wind, etc. So how are they redressing or trying to improve that this time?
Yeah. I mean, those missions were pretty successful. The solar power worked out pretty well, and both rovers lasted well beyond their original designed life. And so that worked out pretty well. But yeah, over time, especially with Mars being a very dusty place, sometimes the power levels will drop pretty low especially in the wintertime. And so that does create a problem. And so, yeah, eventually both rovers stopped functioning. So with both Curiosity and Perseverance, they are nuclear powered. They're nuclear powered, so they can avoid that particular problem. And I believe the nuclear battery, so to speak, has a lifetime of about 13 or 14 years. So it's got plenty of power available to it, and plenty of power to keep the spacecraft warm because it is harsh conditions, especially during the winter. And so hopefully both of those rovers will continue to operate for quite a long time utilizing that power. Yeah. So that's a good question. Thanks, Terry.
Thanks. Thank you, Kevin.
Hey, Kevin.
Yeah.
So I might get this correct. They are just going to leave the core samples scattered along the trail as the rover moves along.
Right, right. Which sounds kind of crazy. Imagine, especially you being a geologist, imagine going
Yeah.
on a field trip and taking all these core samples and gathering rocks, and instead of bringing back to the laboratory, you throw them on the ground.
Right.
But that's exactly what they're doing. Of course,
if we had a student doing that, we'd never bring that student back for research again. It's terrible. So I think the major issue I see there is not so much can they find them, but the dust storms could cover them up and they'll never find them again.
Yeah, I haven't really heard, I got this fetch rover that's going out to look for the samples. I hope they have planned to build some kind of metal detector in there because, what if it gets covered up? What if some of the samples get covered up by moving sand and that sort of thing? I don't know. I haven't really heard anything about that, but as Mark Siegel mentions, it's a lot of litter.
Yeah,
I'll leave behind. I don't think the Martian's going to be too happy.
It would have made sense for just to collect them and put them in a bin and then drop the bin for the rover to pick it up and just take the whole thing back instead of fishing for them all over
the same thing. Right, because it's carrying them now. Right, it has them all now. Why not just shove them back in a slot and then drop them all in one place? I agree.
Yeah, exactly.
Yeah. I don't know what the parameters were for the design team that they created this, but hopefully they know what they're doing. So it is kind of nutty, but
it is nutty. It's nutty. That is nutty.
Does the fact that the atmosphere is all carbon dioxide affect the instrumentation at all?
You mean in terms of corrosion or anything like that, or
anything, right? Just functionality?
No, I don't think so. I mean, carbon dioxide is pretty inert. It doesn't really affect the instruments. I think certainly had a lot of success with the previous rovers. How long did Opportunity? That was the longest running Mars rover. And that run 12 years? Something like that. It was 12 years.
12 years.
That was
and
good.
Spirit ran into a ditch, and that was the end of that one, I think, too. Yeah. But otherwise, who knows? How long both of them could be running for.
Yeah. I think the limiting factor is what Terry alluded to. The batteries really are the limiting factor for a solar power spacecraft. You can, just like batteries here on Earth, you can charge them up and discharge them, and you do it over and over and over again. Eventually, they wear out.
Right.
So that's probably what eventually happened to both rovers. They were certainly Opportunity at the end was still receiving a good amount of sunlight, but the batteries that just couldn't retain a charge, I guess, anymore. Especially under those harsh conditions. I think in terms of carbon dioxide, I think really the biggest factor that is the biggest limiting factor is the temperature, because you can get down to a couple hundred degrees below zero. That's tough on electronics to go down that low. Okay. Any other questions, Jim?
Yeah. Is this the first one where they're actually landing in what would consider a lake bed?
Well, the crater that Curiosity is in, I'm not sure. I'm not sure if you would really technically classify it as a lake, but I think they found enough evidence there that there certainly was water there, at least in part of it. They certainly found. One thing they found was the little, they call them blueberries on the surface. The geologists called them blueberries. Little, I forget what exactly, I don't know if Mark, if you remember what they call those little concretions.
Yeah, concretions.
Concretion is the word I was looking for. These little concretions, and they are dark, and they really kind of do look like little blueberries kind of scattered across the surface. And those only form in water, and you have to have, and we're not talking a puddle, it's got to have, you got to have standing water, a fairly good amount of it for a fairly long period of time for something like that to form. And so certainly where the rover first landed, that area certainly had quite a bit of water in it.
Right. Well, and just looking at the photos that you showed of the surface, is that what I'm thinking about here is as crazy as this sounds. First off, if the sediments are solid, then the on two levels here, that you're not going to hit something that might still have water there, and that you have a crust protecting it. And the next thing you know, the darn thing sinks into it. And of course, you're thinking of temperature here. Plus, also, if you have enough sediment over time, that it's solid and not, semi-solid. Now, again, temperature-wise, just this coldness may act like a cement to keep things frozen together.
Yeah, like a permafrost.
Right. And this is like the fact that it's where it is in a place where you have all these sediments, then ground penetrating radar makes sense. I don't know if with a lot of solid rock that you would really be able to go and get much depth with that type of equipment. So it would make sense that you would go to someplace like this to try to get within the surface.
Yeah. And, I don't know if they really know very much about the subsurface of this particular area, but that's one of the
right, because normally they're setting off little explosions to do seismogram type things to do stuff through rock and such. So this is, if they're doing ground penetrating radar, then they really need to have sediments to do it through.
Right. Sure. Yeah. Good point. Yeah.
It might make sense to take a GPR first to see what the substrate is, the subsurface is below, and then do your coring after that, or at least find the place where you want to core, So that might make some sense why they're doing that. It makes,
So Kevin, I figure the answer is probably yes, but certain if they're going to be sending back photographs, right after they land pretty much, and kind of, showing samples that they may have collected?
Well, if you mean, certainly at the beginning, and that's what the panoramic cameras are for, is they like to kind of map out the area and just look around and see what's interesting. And then, of course, all the scientists or, various teams are probably arguing over which target to go to first. But they often have big arguments about that because you can't. A lot of the scientists, they probably, if you let them look at everything they want to look at, the rover would never move. It'd be in one area looking at for 6 months, looking at this one area at every single little teeny tiny grain. But they do have a path probably figured out for this particular mission that they want to follow, and different areas that they've seen from orbit that they want to get to. And so they're limited into how much time they can spend at each site. And so, they kind of map that out with the panoramic cameras and pick out the stuff that's really interesting and test that, or, look at the rocks and the chemistry, et cetera, and move on from there,
Also, do you know how far the Ingenuity drone can fly from the site?
If I remember correctly, it's not that far. I think it's only about 30 feet. So just this little hop, and I think the flight is like 90 seconds long or something like that. And so it can go up, and I forget what the maximum height is. It go up fairly high and take kind of some overview shots. I think it's got a downward facing camera, and it can take some overview shots and then come down and examine a smaller area. So it's not very far, but at least it expands the scope of the mission, And if that's successful, that will help us build larger drones and more efficient drones that can carry instruments. And that's what what's the name of it? The Dragonfly mission is all about. We'd like to send some kind of flying drone spacecraft to Titan and go fly around in the atmosphere of Titan. That would be really exciting. you know. So in part, it's a really planning for the future.
Do we know how far the coring, how deep below the surface they're gonna core? I guess they're gonna.
Yeah, it's not too much. You know, when you look at the images and the videos, it looks like several inches. You know, it's not very deep. You know, which might be a good thing because the instrument that they designed for the InSight lander was supposed to go, I think, a couple of meters down, and it really hasn't been very successful in drilling down into the surface too far. You know, so perhaps.
Yeah, I was curious if they were trying to get past the oxidized layers near the surface and trying to find stuff that may be anoxic. That they might find better preserved, you know, possible fossils, microfossils or something.
Right. Yeah. Okay. Any other questions about Mars or the Mars Rover? Okay. I don't see any other questions, and so I think we should wrap up this part of our program. And so thanks for being with us tonight. For NJAG members, please do stick around. We want to have a short meeting. And so thanks for everyone else for being here with us tonight. Our next program will be in December. I believe December 9th, correct? Second Wednesday, of course, of the month. So it'll be December 9th. And we're going to have a presentation by one of our members, Jay Gowers. He's going to talk about the Gemini program. It's a very important part of the early crewed space program to get to the moon. And so he's going to talk a little bit about the history of that program. So it should be really interesting. And so come back and join us on December 9th.